Welcome to Tiny Show and Tell Us, the bonus series where you write in with your favorite science story, fact, or piece of news. We read your email aloud and then dive deeper. I'm Sam Jones, the exec producer of Tiny Matters, and today I'm here with science communicator and video producer Alex Danis, who has been an excellent guest co-host in a few episodes already this summer and fall.
You are too kind, but I am super happy to be here hosting a few of these with you and diving into some show and tells from our listeners, which is very fun. Before we get into things, a reminder that Tiny Matters is always looking for you to write in because that's what makes these future episodes possible. You can email tinymatters@acs.org or click the Google form link we put in the episode description. So this is my first Tiny Show and Tell Us, but I'm going to be brave and go first if that's okay.
Amazing. Yes.
So this is from listener Mickey. Mickey writes in, I study atmospheric aerosol. When waves form and crash, they spray tiny droplets of water containing particles in the air. Material at the ocean surface is released in these airborne droplets. Much of the ocean material is biological and can include itty-bitty algal cells. Airborne algae are among us. We do not fully understand their role, but know that their material, like cell walls, are helping to seed ice and clouds in our atmosphere. Thanks, low-floating algae snack, for helping to regulate our climate. I both love the email substance and the email format. So thank you, Mickey. That was very fun.
Agreed.
So before we dive into what algae has to do with clouds, I want to talk a little bit about how clouds form in general. So obviously, clouds are made mostly out of water, but those water molecules need nuclei to form around. So the idea is that water molecules won't really just bond together to form cloud droplets on their own. They need some sort of larger, flatter surface to condense on. And typically, if you think of a water molecule, it's about 0.001 microns, and these nuclei are about 1 micron. So it's way bigger and allows all of these water molecules to sort of cling onto it and create a cloud droplet. So these can be all kinds of different things. We can have wildfire smoke, ocean spray, specks of soil. There's a bunch of stuff up there that attracts water molecules and then condenses. So if you think about it, I think it's kind of cool that, like, if you look at a cloud, it's not just water. It's water plus dirt plus salt plus sea spray plus all this other stuff up there.
I think in my mind, I sort of think of clouds as this very pure thing, but actually they're riddled with dirt.
Yeah, they're kind of dirty. And I know you did a whole thing on like microplastics in rain and clouds a while back. Like everything's up there in clouds.
Yes.
The other thing that's important to cloud formation is temperature. This was interesting to me because as air rises from the surface of Earth, it expands and cools. And that to me feels a little counterintuitive, right? Like typically you think of air expanding as it gets hotter,
right?
But the atmosphere is so big and so cold and so wild and you're approaching the vacuum of space that it actually expands and get cooler. So as that happens, it continues to cool and expand until it reaches something called the saturation temperature, which is also 100% relative humidity. So I think this is also something that we're pretty familiar with. You see on the weather, it's 80% relative humidity. You walk outside, it's disgusting. You see that it's 40% relative humidity. It's lovely. It's nice.
Yeah.
So a cloud is 100% relative humidity. It is wet. So this is the temperature at which the air just can't hold on to any more water in gas form. And so then that's when that water condenses into the cloud condensation nuclei and forms cloud droplets. Typically, this is a natural process, right? There's all this dust and dirt and stuff up there that clouds are forming around. But there is also artificial cloud seeding that you might have heard of before. And this is the idea that we want to try and impact the weather. So maybe there's an area that needs rain, or maybe sometimes it's used to interrupt hailstorms and stuff like that, that we will go up there and we will try and put some of these nuclei up in the atmosphere to seed clouds. And it's typically stuff like sodium chloride, which is just table salt, or maybe
which is
even
so funny to me. Like, let's just throw some salt up there.
Yeah, I know that this isn't how it happens, but I do want to imagine someone in a little Cessna just like shaking table salt out the side of their plane.
Yeah.
There's also potassium iodide, which again is like super safe and in foods and that kind of stuff. So they're introduced into clouds that could, again, maybe influence rainfall, maybe mitigate hail damage. And there are other things they use sometimes for cloud nucleation, stuff like dry ice, which is just solid carbon dioxide, and also silver iodide. That I found was interesting, that maybe some of the clouds raining on you contain silver, which would be the silver lining to your rain cloud.
Majestic.
Exactly. But none of that is what Mickey wrote into us about. Mickey was talking about algae. So we think about algae being in the ocean, but they can also serve as these condensation nuclei for clouds. And there's an algae killing virus that seems to be causing this to happen more and more, which is pretty cool. So a lot of this revolves around a single-celled algae called Emiliania huxleyi. And I looked this up because I was like, that is totally a name. And so it is named after two guys, Thomas Huxley and Cesare Emiliani, who were the first people to look at sea bottom sediment and find coccoliths within it. And coccoliths are these little plates. They're these calcium carbonate plates that surround this algae Emilianii huxleyi. And if you look up pictures of them, think of like a ball that's covered in these ruffled frisbees or like coffee filters. So they're these little plates that sort of cover all around these algae, which are pretty.
I think a little bit about, oh my gosh, what are the animals that are the armadillos, the ones that have sort of that and they can like curl up and be a ball? That's sort of what I think of.
It looks a little bit like that, where it's got these like armored plates around the algae, which is kind of cool. So those plates are called the coccoliths. When the algae dies, those coccoliths sort of fall apart. So you get all these little discs that float down typically to the sea bottom. However, this new virus, which is E. huxleyi virus, which kills E. huxleyi, the algae that we're talking about, it kills off a bunch of these algae at once. And so they shed those coccoliths more quickly. And then those shells sort of stay up at the surface rather than falling down to the sea bottom. So you get all these little calcium carbonate frisbees just floating around at the top of the sea. And then when you have waves breaking and you have water crashing together and you have things dropping into the water and you've got all the sea spray, those coccoliths are really light. And so they can float upwards into the sky where they can become nucleation points for clouds, which is pretty cool.
That is really cool.
It's also, though, not the only time we see algae sort of seeding clouds like this. So there's also been some work that shows that bacteria from big algal blooms, so if you think of red tides, you know, you get a warning from your local health department, don't go swimming in the ocean right now because there's a big algal bloom. That too creates just a lot of algae, as well as a lot of dead algae at the top that can sort of float up into the air in these crashing waves and cause cloud condensation nuclei. So there's a lot of work showing is happening now, but there's also a theory that a big algal bloom, something like 800 million years ago, might have caused lots of this to happen and then lots of cloud formation and been part of what caused that snowball Earth, which was rapid cooling of the Earth 800 million years ago, which caused massive temperature differences, giant extinctions, all kinds of different evolutionary waypoints. So I just think it's really cool that you think of these teeny tiny single-celled organisms and they can actually have giant effects on the atmosphere and on our environment in ways that go beyond just what's eating them, but into them like engineering, not intentionally, but accidentally engineering the atmosphere, which I think is cool.
Yeah, it is really cool.
When we're thinking about those big algal blooms, though, we did an episode on the Reactions channel a few years ago about these harmful algal blooms. And they can be really scary, even if you're not actually going into the water. We did a ton of deep diving into the fact that just the particles and molecules they put into the air can be toxic to you and to your pets. There was a big study that was looking at like dogs who had walked along beaches with algal blooms getting sick too. So I would say if there's an algal bloom in your area, definitely don't go swimming, and also maybe stay away from the beach for a little bit.
Yeah. When you think about like harmful algal blooms, that is a big issue. But a lot of what algae do is amazing.
Oh, in general, our oxygen BFFs, like we need algae. We love algae. Algae is our friend, except when it's not.
Right. Well, thank you to listener Mickey for sending that in. That was a really cool tiny show and tell us.
Yeah. Thank you, Mickey.
Okay, so Alex, I'm going to tell you about a tiny show and tell from listener Mike. So Mike wrote in saying that he has been fascinated by space for a long time, which I think a lot of us can relate to. And he says his fact is that the universe we live in has a wall. And then he adds that most people don't even realize where they are in the universe, how small, how infinite and finite it can be, which, like, yeah, the universe is overwhelming and exciting, but also we know all these things about it, and we're going to get into it. So let's talk about this wall
Okay.
because, in fact, there are many. And what I think Mike is referencing is that a few years back, scientists discovered a wall of galaxies in our universe. And so this wall is at least 1.4 billion light years long. A light year is the distance that light travels in a single year in a vacuum. So it would take light 1.4 billion years to travel across this wall, is what that means. For context, that's about a third of the amount of time that Earth has existed.
It's a very long time. And that's just for one edge of the wall to see the other edge of the wall. That's not even traveling between the two. That's just like light traveling between the two.
Yes.
Crazy.
So a team of scientists reported this discovery of what they call the South Pole Wall in July 2020 in a paper in the Astrophysical Journal. And in an MIT Tech Review article written by space reporter Neil V. Patel, he describes it as, quote, basically a curtain that stretches across the southern border of the universe from the perspective of Earth and consists of thousands of galaxies along with huge amounts of gas and dust.
Does that mean that there's nothing past the wall?
No. So I think that's where this gets really confusing. And we are going to talk about this conversation surrounding, is there a wall at the end of the universe? And is there even an end of the universe? But
Okay.
this is, at this point, this is a galaxy wall. And I'm going to talk a little bit about galaxy walls
Okay.
now. Let's talk about this South Pole Wall. It's just 500 million light years away, a quick trip
Easy.
in universe time. And apparently that made it a lot harder to find because it's right behind the Milky Way in what's called the zone of galactic obscuration, where our galaxy's brightness made it hard to see.
I love that name. The zone of galactic obscuration. Incredible.
I know. A+ to whoever named that. Okay, so how did they find it? There are these cosmological surveys that are done all the time that look at the distance of objects in the universe using something called redshift. It's a shift toward longer or red wavelengths. So if you actually look at a visible light spectrum, you have purple and blue on the shorter wavelength end, and then the wavelength increases as you head towards yellow, orange, and then red. So the further away an object is, the greater its redshift will be. And that's because light waves that travel through space are stretched by the universe's expansion.
Okay, that's also cool because when you were saying that, I was like, oh, I guess they lose a little energy over time. But no, the universe is actually stretching them. That's so cool.
Yes. Side note, our universe is expanding. We actually talked about it in Tiny Show and Tell Us episode 3, where one of the topics that we covered was dark energy. So if you want to think more about our universe expanding, what that means about its beginnings and potential end, go to that episode. But back to these walls. So this team who discovered the South Pole Wall also included the measurements of the velocity of certain galaxies, which then shows how they gravitationally interact with each other and allows them to detect other galaxies that can't be seen because of the bright light of the Milky Way.
Okay.
So by doing this, the researchers were finally able to map out the South Pole Wall for the first time. I went down this big rabbit hole. So truly, when I say thank you, Mike, I really mean it because this kind of stuff is very fun for me. I am equally as in awe as I am perplexed by space. And so this was a scary exercise for me, but it was fun. But what I didn't know is that there are other massive walls of galaxies in our universe.
Oh.
Since the 1950s, scientists have discussed the existence of superclusters, which are large groups of smaller galaxy clusters or galaxy groups. So our galaxy, the Milky Way, is actually part of the local group. The local group actually has over 54 galaxies in it, which I did
big.
not know. Yes.
Yeah.
And so back in the day, scientists were learning that galaxies in the universe seem to be drawn together. But then in the late 80s, scientists began discovering groups of superclusters that were forming massive structures of galaxies. They would call them filaments or supercluster complexes or walls.
Ah, okay.
And so these are the biggest structures in the observable universe. One is called the Sloan Great Wall, It was discovered in 2003, and it's really similar in size to the South Pole Wall because it measures 1.37 billion light years in length as opposed to about 1.5. And it's about 1 billion light years away from Earth, so it's like twice as far. But I believe the largest one is the Hercules Corona Borealis Great Wall, which was discovered in 2013, and it is 10 billion light years in length.
Oh my gosh.
My brain can't compute that, but
No.
it's huge. So something I alluded to earlier, right? Like learning about these walls, it makes you wonder about the edge of the universe itself.
Yes.
Is there a wall at the end of the universe? Is there something beyond the universe? Is there more than one universe? Is this a multiverse situation?
Ah.
Is this all a simulation? No, I'm just kidding. I'm not going in that direction. So I'm obviously, as you can tell, not in the astronomy community. But in this research, it became pretty clear that scientists agree that there's no edge or border to the universe, at least not one that we can observe. So what can we observe, you may wonder, Alex?
I do wonder.
So the distance to the edge of the observable universe is the age of the universe. There's a consensus that that would be when the Big Bang happened,
Sure.
which was about 13.8 billion years ago, times the speed of light. So 13.8 billion light years.
Okay.
But then let's remember the universe is expanding,
Right.
so that affects the travel of light. So some very smart people made some calculations, and that seems to correspond with about 45 billion light years. So that would be the edge of our observable universe.
That is so big.
And there could still be a lot more beyond it, but like we're just going to have to wait around for billions more years, right?
Oh my
Like
gosh.
we have to exist for longer to know how big the universe is, because that is how far light can travel, is really what it means.
Yeah, that word observable in the phrase observable universe is doing a lot of work.
Yeah, it is.
And gosh, I wonder, and I don't think it will happen anytime in the near future, but if we will ever invent some way to like speed up the process of what we can see. Like, I don't know how you would possibly magnify the speed at which light is coming at you at, or some technological way to do it. But
Right.
I'd love to know if a billion years in the future, we have figured out a way to expand what our observable universe is. I would love a sci-fi writer to write that up for me, please.
Yeah, please. I'll read that book.
Me too.
Well, Mike, thank you so much. That was a really fun one to deep dive on.
Loved it. Thanks for tuning in to Tiny Show and Tell Us, a bonus episode from Tiny Matters, a production of the American Chemical Society.
To be featured in a future episode, send us an email with your tiny show and tell at tinymatters@acs.org or click the Google form link in this episode's description. See you next time.